So here we go, 16th question. A stone is shot straight upwards with a speed of 20 meter per second. What is the speed of the stone given? 20 meter per second from a tower of 200 meter high. So you were given a tower whose height was 200 meters. The height of the tower itself was given as 200 meters. And from the top of a tower, a stone was thrown upwards. It moves to the maximum height and again comes back to the ground. So this will be your initial velocity. After reaching highest point, its velocity will become 0. Again, if it reaches the same height, same level, again its velocity becomes 0, same as if thrown from the same height, and again this velocity you are asked to find. So there are two methods, but the direct method I will be telling you children in order to solve this. The one and only one equation to find the relation between the initial velocity u and the final velocity v when displacement is given as v square minus u square equals to 2a. Yes. But what is the final velocity? Which is unknown, we need to find out. And the initial velocity is u. The value of u is given as 20 meter per second. The value of u is given as 20 meter per second, but it is thrown upwards. So whenever it is thrown upwards, the upward motion is always taken as negative, whereas the downward motion is taken as positive. Okay, so as it is thrown upwards, let us keep the value as minus. Okay, minus 20, negative whole square, u square, u is minus 20 whole square equals to 2. A is acceleration due to gravity, which is always acting downwards, and the acceleration due to gravity value is taken as 9.8 and the displacement is taken as 200. That's it. Okay, children? Well, so substituting all the values, we have v square minus 20 into minus 20 is plus 400. So 400 must be equals to 2 into 9.8 into 200. Okay. So if you multiply this 9.8, you'll be getting something like 3920. Okay. So now the value of v square is equals to minus 400. Taking the other side, we have plus 400 plus 3920. Or the value of v square is found to be, this is 0, 2, 3 and 4. Okay, you found that the value of v square is 4320. Value of v square is 4320. The speed with which it strikes the ground, and but you are given 4 values 60, 65, 70 and 75. It is, you feel little difficult to take the square root of 4320. So let us compare among the given options which one is true. Okay, suppose if answer v happens to be 60 meter per second, then v square must be how much, children? If this is v is 60 means v square must be 3600. Okay, 70 means 4900. 7 7s 49. Similarly, 65 means it must be 4225, and 75 means 5625. Okay, so this is the value of v square. The value of v square here is 3600, here 4900, 4225 and 5625. So it asks which among the following is approximately t. So let us check it out. So is 4320 nearer to 3600, 4225, 4900 or 56? This is the vast biggest number, smallest number. So 4320 is nearer to which number, children? So the difference between 4320 and 225 is less when compared to the difference between 4320 and 4900. So hence the correct option must be, so option number 2, that is 65, because if you square 65 you are getting it as 4225, which is approximately equals to 4320. Hence we take option number B as correct. Okay, so well, moving to the next question. A body sliding on a smooth inclined plane. You know the inclined plane, the slope. Okay, a body sliding on a smooth inclined plane requires 4 seconds to reach the bottom. This is how an inclined plane looks like. Okay, and a body is being given, and this body falls slides on this inclined plane, and the time taken for this is given as 4 seconds. Displacement be some s, and it was starting from rest condition. U is given as 0. How much time does it take to cover the 1/4 of the distance? The second case you are asked to find out this. If this is s, then this will be something like s by 4, and here the time is taken as t1. Now you are asked to find the time t2. So t1 is given as 4 seconds, s1 is given as s, initial case. Final cases, distance is given as s by 4, you are asked to find out the t2. But whatever the condition is, we know only one reason, that is what relation between s and t is s is equals to ut plus half a t square. As it is a freely falling body, initial velocity is 0. Hence clearly we have s is equals to half a t square, or s is proportional to t square, because always for both the cases we have half is a constant number, constant, acceleration is same, only time factor is changing. So s proportional to t square. So based on that, if you compare the two things, then we get something like this. So s1 proportional to t1 square and s2 proportional to t2 square. Let this be equation 1 and this be equation 2. So let us divide the two equations, 1 upon 2. Then how much you will be getting? s1 by s2 equals to t1 square by t2 square. Substituting all the values. S1, what was the initial distance that was given, children? Yes. S2 is 1/4 of the distance you are asked to find out. This is s upon 4, s by 4 is equals to initial time, it's given as 4 seconds. So 4 square upon t2 square, which you need to find out. So solving the two, we have s and s gets cancelled. This denominator 4 will go up. Then your result will be something like this. 4 must be equals to 4 square means 4 into 4 upon t2 square. So solving these two, we have 4 will get cancelled. Bringing this t2 square the other side, we have t2 square equals to 4, or t2 is equals to square root of 4, that is 2 seconds. Hence your final answer must be 2 seconds. So from the one and only one formula, s is equals to ut plus half a t square, freely falling body, u is considered as 0, so s is equals to half a t square, or s proportional to t square. So comparing the two conditions, one is s1 is s, s2 is s by 4. S1 is yes, S2 is s by 4. T1 is 4 seconds, T2 you are asked to find out. So dividing these two, you get the relation. Well, moving to the next question. Next question, 18th one. A stone dropped from a building of height h and it reaches after 2 seconds on the earth. So simply a stone is dropped from a height h. Well, it is an example of a freely falling body. From the same building, if two stones are thrown, one upwards and other downwards, with same velocity u, and they reach the earth's surface after t1 and t2 seconds respectively, then you are asked to find the relation between the very first body, that is when it was freely falling, second case when it was thrown upward with velocity u, and the third case thrown downwards with velocity u. So three different timings it is taking. One was t, the other was t1, the other is t2. You are asked to find the relation between them. So first of all, let us find out for a freely falling body. In the case of a freely falling body, you know that the first case, very first case, freely falling body, okay, dropped. General formula is s is equals to ut plus half at square is your general formula. But as it was a freely falling body, initial velocity is 0. Hence s is equals to half gt square will be your equation for the freely falling body. But what was the distance traveled? The distance traveled was the height h. So substituting all the values, s is replaced with the h. Okay, so s is replaced with h equals to half g t square. Let this be equation 1. So what is the first case, children? When a body was simply dropped, we got the relation as h is equals to half g t square. Now moving to the second case. What was the second case? From the same building means same height. S is again same. 2 stones are thrown, among which one stone was thrown upwards. Whenever a one stone upward thrown body, the formula for an upward thrown body was H is equals to minus ut plus half gt square. I hope you remember this formula. For an upward projection, H is equals to minus ut plus half gt square. So this will be your second case. So that second case, let me write it the second case as H is equals to minus ut. H is equals to, what is that, children? Minus ut plus half g. But what was the time taken for the second stone to again reach back the same position, that is t1. In this case, the time taken to reach the ground was t1. Hence the second equation will be replaced with H is equals to minus u t1 plus half g t1 square. So the time is replaced. New time it took because it has to go up and again has to come back to the ground. Well, so this was your second equation. Now moving to the third case. From the same building, again from the same building means the same height it was given. So S is H equals to. But what is the case? It was thrown downwards. Whenever thrown downwards, the equation will be again ut plus half gt square. But in this case, the times are given as t2. So the times are given as t2. So this will be our third equation. So let us also write the third equation. What is the third equation, children? H must be equals to u t2 plus half g t2 square will be your third equation. So these are the 3 equations. So based on the 3 equations, you need to get some relation between the t, t1 and t2. First of all, children, if you observe first 2 equations. What are the first 2 equations? First 2 equations. So let me write it here, children. From equation 1 and 2, left hand side. In the first equation also left hand side you have the value as H. Second equation also you're having H only. So left hand side are equal. Hence equating right hand side. So what is the equation in the right hand side? Here you have half g t square must be equals to, in the second case, minus ut1 plus half g t1 square. So as left hand side are equal, I just equated the right hand side part. So right hand side half gt square and here the right hand side minus ut1 plus half gt. It's clear, children? So now let us arrange the terms in a proper way such that some common factors you may get. So what I do is I'll bring minus ut1 to the left side. If minus ut1 is brought to the left side, how much it will be? ut1 plus ut1 equals to. So keeping this half gt1 square as it is, bringing this plus half gt square to the other side. Plus half gt square comes the other side will become minus half gt. Is that okay? So ut1 is equals to half gt1 square minus half gt square, or ut1 is equals to, what are common here? Half g is common. Then you are left with t1 square minus t square. So let us keep this aside. So this equation, let us keep it aside. So as we have equated 1 and 2, we got this relation. Similarly, let us also equate the small value equation 1 and the bigger value equation 3. So what the next step would be something like this. Again, from equation 1 and equation 3. 1 and 3. Here also if you compare, left hand side are equal. So left hand side are equal means again equating right hand side. So what are the right hand side in this equation? Half gt square. Again in this equation, let us substitute. Yes. Case 1. Half g t square equal to the third case, because 1 and 3 now, 1 and 3. What is the value in the third equation? ut2 plus half g t2 square. Okay, again bringing all the common values to one side and taking the values to the other side. So here half g, no more negative sign is there. So what we do is keeping this ut2 here itself. Keeping this ut2 here itself, let us take this half gt2 square the other side. Then how much it would be? Half g t square, this value, and this when comes to the left side, it will become plus half g t2 square will become minus half g t2 square is the value of ut2. I just kept it here and brought this to the other side. Here also, if you compare these two, what are common? Half g is common. So taking half g as common, what are you left here? Half g taken out means you are left t square minus, and here you left with t2 square is the value of ut2, is the value of ut2. Again, so two relations we got. So in this, let me also name these equations as this one be some fourth equation, let this be some fourth equation, and this be fifth equation. I hope complete concept is clear, children. Three equation: freely falling, upward thrown, and downward thrown. Freely falling, time was t, upward thrown, time was t1, downward thrown, time was t2, and velocity was same u, but the equations were changing according to the relation. Comparing, equating 1 and 2, we got the fourth equation. Equating 1 and 3, we got the fifth equation. Now the next step, coming to the next step, what we do is, let us divide two equations. What are the two equations? So now let us divide two equations, those two equations as equation 4 upon equation 5. Let us see what may get. So what is the left hand side of equation 4 is ut1 upon left hand side of the fifth equation is ut2 is equals to, in this case right hand side is half g t1 square minus t square upon, here right hand side is half g t square minus t2 square. Is that clear, children? ut1 by ut2 equals to half g t1 square minus t square upon half g t square minus t2 square. That's it. So simply solving this. Properly, carefully solve it, children. So this u and this u gets cancelled. Half and half gets cancelled. G and g gets cancelled. Now we are left with t1 by t2 equals to t1 square minus t square upon t square by minus t2 square. So taking the LCM, bringing this here and the other part here. So t1 into, what is the value? T square minus t2 square must be equals to, bring this the other side, t2 into t1 square minus t square. Just so cross multiplication. t1 into t square is t1 t square minus t1 t2 square equals to t2 t1 square minus t2 t square. Here if you observe carefully, we need the relation between t and t1 t2. So t is one side and t1 and t2 are other side. So what we do is, let us bring all the t terms to one side and the leftover terms to the other side. So here also t is there, again here also t is there. So let us bring this term to the other side and let us see what happens. t1 t square, this minus symbol, if you brought the other side of the equal to, this will become plus t2 t square equals to. So this I already removed. Then what are you left with? t2 t1 square and minus t1 t2 square, bringing to the other side, right side. Minus will become plus, what is the value? t1 t2 square. Clear? Almost done, children. Don't get panic. Almost done. So here, what is common in both? This is t1, okay, and t square. So here also t square is there, here also t square there. So let us take t square as common. So if you take t square as common, then how much here left? t1, and here you are left with t2 equals to, here also t2 in this, t2 is also here, t1 is here, t1 is also, so both t1 and t2 are common. So taking t1 and t2 as common, I removed t2, I removed one t1. So what are you left with? Only one t1 is left. So I wrote a t1, okay. Just go through this. T1 T2 into T1 is T1 square T2. Clear? T1 square T2 plus symbol. So already I took off T1. I already took off T2. Then only one T2 was left. So this T2 I kept it here. Observe the right hand side part and left hand side part of the last equation. So here also T1 plus T2 is there. Here also T1 plus T2 is there. Hence very clearly we are left with T square is equals to T1 T2. Isn't it clear, children? So T square is equals to T1 T2 or T equals to under root T1 T2. This must be your final answer. Little lengthy, children, but not difficult. So please go through it carefully. Without any mistake, you'll get the answer. Okay, so what is your final answer, children? Option number C, that is T equals to root over T1 T2 is the correct answer. That is what we got. Okay, 19th question. Water drops fall at regular intervals from a tap which is 5 meters above the ground. The third drop is leaving the tap at instant of first drop touches the ground. How far above the ground is? So for this, what we consider is, let us try to consider a tap. From this tap, water droplets are falling something like this. Okay, this might be first drop, second drop and third drop. What it was given is the height from which it is falling is given as 5 meters. Okay, and it was given that they are falling at regular intervals of time. So underline this, they are falling at regular intervals of time is, so the equal time factor. Okay, suppose if the first drop comes for t seconds, means the second water drop also travels for t seconds. So the time fraction is same. Okay, 1 second means every after 1 second the next water drop may come, like that. So every fraction of time the water drop comes outwards. So that you need to remember. Okay. The third drop is leaving the tap, but then first drop, when this comes and reaches the surface of the third drop comes out. So how far above the ground is the second drop? You are asked to find this height h. Question is clear, children? The total height was given as 5 meters and this is coming down at every regular intervals, means from here to here if it would have taken t seconds, here to here also it would have taken t seconds to travel. This is very clear that it is an example of a freely falling body. So from our equation S is equals to ut plus half at square. For a freely falling body we take it as S is equals to half gt square. Height. For the first case, first water drop from here to here it has traveled, so distance is taken as 5 meters is found to be half g. Let me take it as g only. Later I will substitute whether it is 10 or 9.8. T square. Here it is t, here it is t. What is the total time, children? 2t. So 2t whole square. Okay. So simplify this. 10 can be written as 4 g t square. Simplify this. This 2 I brought it here 10. 2t square is 4t square into g is 4g t square. That's it. Or t square can be written as 10 by 4g. This will become 5 by 2g. Okay. So t square. How far above the ground is the second drop at that bottom? Let us see. Only t value we know, nothing else. 20. 5 by 25 was, yes. Let me substitute t as 10 only. 5 2's 10, that is 1 by 4. If t square happens to be 1 by 4, t will be 1 by 2. That may help us. So here based on the requirement I substituted the value of g as 10. So that I got the value of t as 1 by 2. If you go with 9.8 means the solution will be complicated. So I took the value of g as 10. Hence I got the value of t as 1 by 2. Again, if you consider the second drop for the freely falling motion, this part, this distance, let me take this distance as some x. But you are not asked to find x, you are asked to find out h. But For my easiness, I only know that it is a freely falling body. First of all, let me consider the value of x. Again, the same formula, s is equals to half gt square. We have x is equals to half g. This time interval is t square. That's it. So x is equals to half, g is now 10 into t square. T just now found as 1 by 2. T square means 1 by 4. Hence, your option will be 5 by 4. So this portion was found to be 5 by 4 and this complete length height was found to be 5 meter. So you are asked to find out this value h. Hence the value of h, clearly 5 is equals to x plus h. Okay, h plus x. Okay, clearly h plus x, total height is found to be 5, or h is equals to 5 minus x. So this is implies h is equals to 5 minus 5 by 4. What is 5 minus 5 by 4, children? 20 minus 5 is 15 by 4. What is the value of 15 by 4? Therefore, the value of h is found to be 4 3 is 12, 3.30 means 7 4 is 28 to 5. That is 3.75 meters. Okay. So, what height? Second drop is at a height of 3.75 meters from the surface of the earth. Clear? From the ground. Next question, 20th. A stone thrown upwards with a speed u from the top of a tower reaches the ground with a velocity of 3u. The height of the tower is, again the same question, tower is there. Okay, from this tower, the body is thrown upwards, it may fall downwards. Okay, what velocity they have covered? 3u velocity. The height of the tower is, yes, the stone is thrown upwards with a velocity of u. Finally, it becomes 0. Again comes back. So, same in height means again here also u and reaches the ground at a velocity of 3u. You are asked to find out the value of h. Simple. From our formula, v square minus u square equals to 2as. V square means how much? 9u whole square minus. This is an example of a free fall. So, u square is equals to 2. Free fall means acceleration is taken as plus g and height you are asked to find out. 9u square, this is 3u square. Okay, 3u whole square minus u square. 9u square minus u square equals to 2gh. Or 8u square is found to be 2gh. But you are asked to find out the value of h. This implies bring this 2g downwards. 8u square by 2g equals to h. 2 goes 4 times, hence the value of h is found to be 4u square by g. h is found to be 4u square by g. Hence option number B. Next question, that is 21st question. A stone dropped from the top of the tower touches the ground in 4 seconds. How much time it took? 4 seconds. Where was it thrown from? From the top of a tower. This is the tower given. Stone was simply dropped down. That means initial velocity is 0. Okay, in 4 seconds. Time was given as 4 seconds. The height of the tower is. It's a generalized question. Okay, so S is equals to freely falling body is S is equals to half gt square because initial velocity is 0. So S here is nothing but the height equals to half gravity because it is in zeros are there instead of 9.8 I take it as 10. Time is 4 seconds means 4 into 4. Okay, t square. Hence 4 2 is 8. 8 into 10 is 80. Hence height is 80 meters. Option number A. So, 21st, first question. Moving to the last question. A body is released from a great height and falls freely towards the earth. Another ball is released from the same height exactly 1 second later. That means what is the time interval? If the first body travels for 2 seconds, the other body must travel for 3. The first body travels for 1 second, the other body must travel with lesser time. Okay, so a body is released from a greater height and falls freely towards the earth. Another ball is released from the same height exactly 1 second later. Okay, that means the latter body takes lesser second. Okay, if the first body travels for x seconds, second body would have traveled x minus 1 second. The separation between the two bodies are 2 seconds after the release. This point you need to understand. So that means if the first body travels for 3 seconds, the second body would have traveled only for 2 seconds. Like that you have to consider. So the release of the second body is, so for this what you have to consider, the traveling S is equals to, because it is a released means freely falling body. So what formula are we using for both the cases? S is equals to half gt square. Only difference is time difference. So first body, if you consider, it travels for a distance of h1 half g. If it takes 3 seconds to travel, second body would have only taken 2 seconds to travel, because 1 second later it was thrown. So you are asked to find out the separation between the two. Separation means h1 minus h2 you are asked to find out. What is h1 minus h2? Half g 3 square minus half g 2 square. Now simplify. Therefore, the separation is given by h1 minus h2 is equals to half g into 9 minus half g into 4. Take out common half g. You are getting with 9 minus 4. What is that value? Half into, everything in multiples of 9.8 is there. So g value here I took it as 9.8 into 9 minus 4 is 5. That's it children. 2 goes 4.9 times. So your answer is 9 5s 45, 5 4s 20, 24. So final answer is 24.5 meters is the separation between the two bodies. So option number D, 24.5. So okay children, so from with here we have finished the worksheet 7 from kinematics. Okay, so keep practicing children. Okay, so thank you.